Before wrapping up this module, I wanted to answer a few frequently asked questions about EF Core and database connections, with the goal of ensuring that you're aware of these capabilities of EF Core. The first FAQ is about dynamic connection strings. Although my console demos simply hard-coded the connection string into the DB context, you might have noticed the many times I pointed out that this was helpful for getting you started with your EF Core education, but definitely not a recommended practice. In the ASP.NET Core module, you saw how the connection string was stored in appsettings.json, and I was able to read that when setting up the service to instantiate pub context. Storing connection strings in files that aren't compiled into your code is a common way of dynamically introducing connection strings. You can modify or replace those text files without having to recompile or redeploy your application. And in fact, when we told ASP.NET Core to look for the connection string, appsettings.json is only one of the places that it looks for configuration information. Another place is in your computer's environment variables. And there are other places it searches as well. So there's lots of ways to store and read those connection strings. What about other ways to use them? EF Core has a feature called interceptors, which allows you to tap into EF Core's pipeline. And one of the things that you can do in there is make modifications to an outgoing command. This is a pattern you could take advantage of to inject a connection string. The ability to avoid hard-coding your connection string is especially important when you need to include credentials, and there are quite a few ways to store the string or just the credentials and read it as needed in your code. Felipe Gavilan has an interesting blog post that demonstrates a number of examples. And if you're using a service like AWS or Azure, they also provide a number of ways to store and retrieve secrets. Here's another FAQ. What about reusing connections and connection pooling, or even DB contexts? To answer the first question, database connection pooling is controlled by the database provider. However, there is another kind of pooling in EF Core, which is DB context pooling, allowing EF Core to reuse instances of a DB context rather than instantiate new ones each time. Instantiating a DB context isn't actually that resource intensive, but when it comes to web applications, especially highly transactional ones, there are definitely times when you can gain performance improvements by pooling those DB contexts. It's easy enough to switch from the standard way of instantiating a context to using pooled ones. Instead of using the service's addDBContext, you would use the addDBContext pool method. And then whenever an instance is needed, EF Core will check the pool before creating a new one. There is some additional benefit with DB context pooling that helps with database connection pooling and pooling other database resources. So that comes for free along with a pooled DB context. You can learn more about this from the EF Core docs at bit.ly/poolingdocs. The last FAQ I want to address is what happens if the connection to my database gets dropped when I'm in the middle of executing a command. EF Core has a feature called connection resiliency. It's not on by default, but you can easily configure your provider with the enable retry on failure method, just like we've done with use SQL Server and other configuration methods. What this does is reads the code that the database returns indicating the reason for the failed connection, and that's from a list of known codes. And depending on the code, it will retry the command some predetermined number of times. While this feature does have its default behavior, it's also possible to tune it to your own needs. I've created a shortcut to the documentation at bit.ly/efcresiliencydoc. You've gotten a good overview of some important topics around EF Core's database providers, and this should be really useful for planning ahead, and you can dig further into the topics as needed. While different databases might have variations in their features, the work you do with EF Core to query and update data will almost always be the same, and the same as what you learned in this course, but the provider handles the specifics for its particular database. Interacting with a database that isn't even relational is such a great example of this with the Cosmos provider. However, with a non-relational database, you really need to be aware of how to model your classes and how to configure the provider. But when it comes to querying or modifying data, there's very little difference between what you saw in working with SQL Server. Transactions are an important part of database persistence, and now you know that not only does EF Core protect you with database transactions by default, you also have the possibility to take granular control of how that works. Then I ran through some FAQs about various ways to implement dynamic connection strings, connection pooling, which now you understand is controlled by the provider, DB context pooling that was designed for ASP.NET Core to help with very busy websites, and also how EF Core can help out when it's having a problem connecting to the database. In the next and final module, I'll give you a similar overview of ways to tap into EF Core's pipeline so that you're empowered enough to know what path to go down to solve particular problems. Here are resources and links for you related to the variety of topics that I covered in this module. I'm Julie Lerman, and thanks again for watching Entity Framework Core Fundamentals.